How does a satellite orbit? What keeps it up there? The answer is to do with some of the ideas of gravitation first defined by Isaac Newton 400 years ago. Newton said that apples which drop off a tree were pulled by the same force that kept the moon going around the Earth. He called this gravity. If you throw an apple into the air, gravity pulls it back to Earth. If you were to throw an apple hard enough, it might do something like this, before disappearing into space. If you didn't throw it quite as hard, it wouldn't fly off completely, but instead go into an elliptical movement. Gravity pulls it to the center of the Earth, but its momentum keeps it traveling around. If it's moving fast enough, the Earth's horizon falls beneath the object more quickly than it is pulled to the center, so it falls in a continuous ellipse around the Earth. And this continuous movement is called an orbit. Let's say now you were able to tweak this path with little adjuster rockets. You could nip and tuck that ellipse to being a nice, perfect circle. That would then be called a satellite in circular orbit. Let's say you were to fire off a whole set of apples into space. The ones you throw hard would go far out into space and end up orbiting slowly. The ones nearer would be going faster. If you got it just right and managed to throw an apple to around 36,000 kilometers above the equator, you would find an orbit where your apple is going around at exactly the same angular speed as the Earth is turning. This is known as a geostationary orbit. The satellite would appear to stay still to someone watching it from the Earth's surface. This is very useful to scientists and technicians because they always know exactly where it's going to be in the sky. We use all these principles to launch satellites into geostationary orbits, where they relay signals for TV, internet, and many other services.